Today, I'm going to show you how you can start a new project inside the Edwards EST3 SDU software utility program. So what you're going to learn today is how to start a new project, how to add some devices, how to add the message labels, and create some rules to see if we can get it to compile before we download to the actual fire alarm control panel. We're not going to actually download to the fire alarm control panel, but we're going to see if we could actually get the rules to compile. So if the rules compile, then that means we have a good solid program and we could actually use this on a system to make it work in the way we design it. So the first thing we want to do is go up to project and click on new. You want to give this a name, and you also want to give it a password. You want to give the project a password too. Use the same password that you put in. We usually do 3333. That's the level 3 default password. So now that we have a new project open, this is what's going to be the user label line 1 and line 2. It's what's actually going to be displayed on the fire alarm control panel when it's normal. So we could put, 123 Main Street, something like that. Or you could put the full address of the system, of the actual building. So in operations, everything here is usually left default. Water flow silence means that when the water flow goes off, you won't be able to hit alarm silence, and the alarm will still keep going off. Alarm silence, audio only, or visible and audible. This is saying when you hit the alarm silence button, you just want the horns or the speakers to go off, or silence, I should say. Now here in timing, you could have you could set some delay timings for reset, trouble, AC power supply, things like that. If you have a network system, rather it be another EST3, another CPU out there, another node, or EST3X, this is where you would configure that, the baud rate, the type of class you're using for the data and audio. And you have your trouble reminder. Once you silence a trouble, usually every 8 hours by code, that should remind you that you still have a trouble. And time sync is when you hook up your laptop, make sure that the time and date and all that is straight. So now we just click OK to create the project. And inside here, we have the cabinet, we have network routing, modules, ports, and then we have options. So inside of the cabinet, this is going to be the type of back box you have. What type of back box is it a 3 cab 27, 3 cab 5, 714? These are the big cabinets that has 3 bays. So you could fit 7 cards in each one of the bays. So you could put essentially 21 cards in one bay if you don't have a CPU. So this is saying what type of rail chassis it is. Like I said, you can have 7 cards from 0 all the way over to 7. Network routing. Now, what this means is what messages are going to go in between cabinets, or if you have multiple nodes, what messages are going to go in between the nodes. Are we going to send all the messages from this panel? Any off normal condition or any alarm condition will be sent through the network or to different cabinets. That's what that's saying. You could actually turn that off. So if you have 2 panels and one panel, you don't want to send the information over to panel number 2, you can shut that off by turning these off to no cabinet routing and only display the local issues at that particular panel. It won't send it over the network. Modules, this is how you will add your devices or your hardware inside of the cabinet. So you have your CPU and a power supply. That's standard at all times. So the CPU will take up 2 addresses. That'll be the first 2 blocks in the top bay of the EST3 cab 21, and the power supply will be right next to it. And the power supply module will be right next to it, but the actual power supply will be behind it. So the first 3 slots is taken up for any node, any main fire alarm control panel when it comes to EST3. So the next slot over there, you will be able to put either a ModCom or your SDDC card. So we're gonna put let's put an SDDC1. That's a 2-loop controller where I could put 250 devices on it. We're not going to put anything else on here because we don't need to. But if we had like phone lines hooked up, then we would put the ModCom and then program the ModCom to send out the signals to Central Station. But for now, we're just going to add the loop controller because that's all we really need. And on the operator layer, see now here we have 2 layers. We have the hardware layer, and we have the operator layer. The hardware layer is the physical cards that you see when you're looking at the fire alarm control panel. The operator layer will be used for your LEDs and switches. So you will put your LEDs and switches on the operator layer, so that way you can configure your LEDs and switches, tie your lights up to fan restart or fan shutdown, or whatever you want to do with your lights, you can do that, or however you want to control the system with switches and LEDs. So now that we go over to the ports, this is asking us what type of port is it? Do we have a printer? Do we have CDR hooked up to it? So if there's nothing hooked up to it, we just leave it as none, because there's no baud rate. We're not doing anything with it. The message enunciation group is always going to be default. Inside the options, where we could check off what we want happening to alarm, supervisory trouble, and all those different types of signals, we have the baud rate we can change. We leave all of this default. We could log what we want to log into history. We can uncheck or check it. Everything here stays default. So now after we went through all of that, we went through the networking tab, the modules, the ports, the options. Now we have to add the devices to the SDDC. So we will go back over to modules, and we will select the LRM label, and then we will go into LRM config. So here inside, now we're inside of the dual loop controller. We have loop 1 detectors, loop 1 modules, loop 2 detectors, and loop 2 modules. So you can have up to 125 detectors and modules on a loop. This dual controller can have 500 points, 125, 125, 125, 125. So if we want to add some detectors, we would click on add detectors. What type of detector are we adding? There's different types of detectors that this system have. Do we have 3D multi-sensor? That's the smoke, photo, the smoke, heat, carbon, those combination devices. Is it a fixed heat detector? Is it a heat CO? Is it an ion smoke? There's no ion smokes. It's all photoelectric now. So what we have some photoelectric smokes, or is there a duct detector? We're just identifying the particular point type. All these point types are just all alarm point types, but it does matter what you pick, because you want to have the right point type for the right device. So these are smoke detectors. So we're going to add 1 smoke detector, because our system is small. We just have a smoke, a pull, and a control module, and also like an input device. So inside of the loop controller for the detectors, we have 1 smoke detector. And here we could put our label. I like to do everything in caps, and we could just label that smoke 1, because the label text is what we're going to be using to define the rules. And if you have more than 1, you know what? Let me add 5 more. And if you want to add multiple devices, you could just add multiple devices by just clicking them in, just like how I'm doing here. You know, if you wanted to add like a duct detector or heat detector, you could add all the devices all at once. So we click OK, so that way we have multiple devices. And I'm going to erase this, because I'm going to show you a quick way to actually label these devices. Now we want to add some modules. Let's add a pull station, because like a CT1, or actually like a SIGA 278. That's the dual action pull station. Also, we want to add water flow, and this is going to be using a CT1. Door control, which is this is going to be using a CR, not a CC1. You can use a CC1 if you need, but I like to use CRs. And then we're going to have fan control. We're going to use also a CR. Yeah, I think that's let's put this on normally open latching. Yes, because we want this to stick an alarm. We have to verify the signal to make sure it's actually clear before we could actually reset the system, meaning this water flow point needs to be reset before we could reset the system, before it can go normal. Now we have our devices added into the dual loop controller. So we have some tabs up here. The only tabs that I normally use is like the AND groups, the service groups, and the zone. So an AND group would be if I have, let's say, 5 smoke detectors in one group, and I'm in a particular area and I want more than one of the smoke detectors to go off before any output activation, I will put them in this AND group and select number 2 to say that inside of this group I need at least 2 smoke detectors to be in alarm before any output activation. So that's how you kind of work an AND group. And service groups, you could say, like, if you have a high-rise building, let's just for argument's sake, you got 4 floors, and each floor could have all of their devices inside of a service group. So you could have floor 1, floor 2, floor 3, floor 4. You could also program that in the rules to a switch, so that way you could create a service group for the 4th floor, so you could disable the outputs on the 4th floor. You could run up there, go test the smoke detectors. The elevators won't recall, like the output functions won't happen, because you could put all of the devices within that floor into one service group, so you could just disable that whole entire floor. And same as zones. Zones kind of work like, and groups, or if you could, group areas, devices into one particular zone, and then you could write a rule for that one zone to activate an output function. So when we inside of the object configurations, we have the search field, where we could search by device type, address, labels, and modules and sensors. Here, if we have more than one cabinet, you'll see all of your panels here and everything inside of each of the panels. And you can go straight to, the card or the panel that you need to go to. Here over in the device type, you have all of your different types of devices: smoke, pulse, relays, stuff like that. So you could also navigate to this menu here to quickly get to whatever you want to get to. So if you want to get to the smoke detectors, you get straight to the smokes. So now how this works here with the smoke detectors, we have label text and we have our messages. Our message is actually where the device is located. So this would be, ground floor, electrical closet, something like that. So I'll think of some labels when I get to that point. So in the message text, instead of us, especially if you have, let's say like 200 smoke detectors, each one has to have their own individual label. You can't have this say smoke and this is smoke. You're going to get a syntax error because unique label. Some systems, when you're doing either custom controls, rules, programming, whatever you call it, you can manipulate the fire alarm programming either with the address M1-1, do this, or you could manipulate the fire alarm control rules with the label text. So how Edwards works, you have to label each of your devices with a specific label. So how we're going to do this is, let's say if you had 500 smoke detectors, you wouldn't want to do this individually. So what you would want to do is down here, you see you have some information down here. We could pick all. So that way now we select all of our smoke detectors within this one smoke detector device type group. Then we'll go over to the prefab labels. When we over at the prefab labels, we could have already pre-custom prefabs that we could use. But if we don't, we could just create one. But we already have one here. So we're going to use this smoke_star. Now the star is going to differentiate each one of the smoke detectors. They all could have the same smoke, but one character has to be different, not lowercase, uppercase, but it has to be one character different to make it different, right? So now what we want to do here is just replace this. We want to start with the value 1, and the width, all this is going to be default because we want to just start with the value of 1 because we have 1 through 5. So let's say if you was adding 10 smoke detectors and it was up to smoke 9, you would want to start the value at 10, if that makes sense. So our value is going to be at 1. We're going to replace it. And as you see, we got smoke 1, 2, 3, 4, and 5 instantaneously using the prefab label. Now that we have our label text instantly made, now we're going to give these guys a message. So everything is going to be on the first floor. So first floor, elevator lobby, save. It's going to be first floor, all smoke detector. First floor, storage detector. First floor, lobby. And what I'm doing is I'm hitting the space bar so that way I can get it on the second line. So that way, if I don't, then it's going to be cut off like this. You see how this is? First floor, smoke, D, and then Ecta. You know what I mean? You don't want that it'll look crazy. So what you do is you hit the space a few times so that way you can get to the second line. And then you click save. And this is going to be first floor above FACP. All right. So now that we have our smoke label text and we have our smoke messages, we have to go now and define our water flow. So we're going to call this water flow, or WF_1. We're going to call this basement sprinkler room water flow. What else did we add? We added some relays, right? No door controls, right? So we're just going to call this DR_1. The label is be easy. First floor door release. What else we got? You could click the menu and click it again and then use the up down arrows to go through all the menus to see what you don't have. So this is a fan, so we're going to go fan_1. And like I said, you could have your own naming convention as long as it makes sense to you. And when you write your rules, you just have to remember what your label text are. So a lot of times when I'm dealing with a large system, I write these label text down on a separate piece of paper. So when I get to the rules, let's say if I open up the rules, because I'm jumping ahead, if I open up the rules and start to edit the rules, now I'm on a whole different page. So now I got to jump back and forth to figure out what the label text are. So what I like to do is just when I create my labels, I write my labels down on another piece of paper, so that way I know what rules I need to write. But you also get the information from the sequence of operations on what the rules should be, more or less on what the output should be. So we got the pull stations, pull 1. So we're going to call this first floor stair A. Each device has to have its own, just going through all the menus to make sure we have all of the label text, because it'll give you like an error, but what you call it, like a soft warning that, you know, some messages or some devices is missing a label text. It's like a yellow warning. There you go. It's a warning. It's not an error. It's a warning. So now we want to write our rules. Remember, I said how we write the rules is from the label text. So we go inside rules, edit rules, and here's some rule parameters. If you're using the French brackets, open and close, anything inside here will be ignored. So usually we'll put, you know, your information, something like that. But usually you could put a little description of what the rule's doing. It's a general alarm. Do you have, you know, floor above? What is it doing? Give me an explanation of what your rules is doing. And you could either put your name, your not your address, but like the building's address, or you could put the company's information in this part here in between the French brackets. I'm gonna move the mouse over. I just want to go over a few syntax. The comma, very important. Semicolon, very important. This closes out the statement. The colon, very important. And the quotations, very important. These are all the qualifiers that need to be put inside of the rules, whether it's on the input side or the output side, in order for the statement to go true and move to the next one. So let me show you what that means. So if you watch my video on how to write a rule, you will understand that you need a rule qualified. And what we're going to call this is, we're going to use regular brackets, and we're going to call this general alarm or smoke activation, but we're going to call this general alarm. Before we write the rules, let me just add one more thing. I want to add outputs, which is the CC1s. So we go back over to the SDDC card, and we go over to loop 1 modules. We're going to go add modules. We want to add supervised output, which is going to be an audible. Another supervised output, which is going to be a visible. So that way we have 2 CC1s, and then we're going to click OK. And we're going to put the label here. You can put the label here, or you can go back into the objects and put the label if you have multiple of these point types. But this is going to be really quick. So I'm going to just go horn 1, and I'm going to go vis1, or visible. So now that we have our output devices, so the first rule we want to write, you have to start with a regular bracket, and we're going to call this general alarm, because all we're doing here is turning on everything. Close the bracket. That is our rule. This is going to be our rule label. General alarm is our rule label, and we have our input equation that we have to write, or our input statement. I'm mixing systems up. So our input statement, we need the event. So what is the event that we want to do? Smoke detectors go into alarm, right? We can go alarm smoke, then we put the quotes. Now remember the labels we did, smoke SMK_1 through 5. So what we want to do is we have to mimic that SMK_, but instead of putting, if we just put 1 and close it out, the rest of the smoke detectors will not work. So in order for this qualifier to work for all of the smoke detectors, we have to put a wild card. This wild card will represent every last character within this label. So that's why you can have 500 smoke detectors, all be smoke_, but it could be 1 through 500 because each one is unique. And you use this one qualifier will represent all 500 smoke detectors. So now what we want to do is we want to put our divider, which is our semicolon or our colon. I keep getting those confused. And then on the output side, what do we want to do? We want to turn on audible. Audible is our horns. So we're going to go horn. And being that we only have 1, we could just label it as it is, horn 1. Now we have to use the comma to go to the next output statement. What else do we want to turn on? On visible. which is our strobes. So what did we name that? Viz_1. What else do we want to turn on when the smoke goes off? Next outputs we want to add, we want to shut the fans down and we want to release the doors. So we go on fan control, quotes, fan_1. And if you have multiple fans, of course, you can use the qualifier comma. You want to use the comma so that way you can go to the next output statement. We want to turn on the doors or activate and release the doors, door control. And what's the label text for that? dr_1. And here, we want to put the semicolon to end the statement. We want to save this. We want to see if this rule will actually compile. If it doesn't compile, then it's going to give us a syntax error, letting us know where the problem is at, and then we can come back and fix it and try again. So we're going to save that. We're going to go File, Exit. We're going to close the objects labels. Once we close the objects, we're going to go over to the rules, and we're going to go to Rule Compile, and we're going to see what happens. So it's telling us it's 5 input, output, correlation warnings. Do you want to view the warnings? Yeah, let's take a look at it. So it's telling us that there's a couple of point types that we didn't add to the rules, like the pull station, the water flow. We haven't finished programming the rules. So it's giving us the alarm point types that need to be programmed just in case they go into alarm. They need to know what to do. So go back to the rules, compile, let it compile again, but we're going to say no this time. Now the rules has completed successfully. So now do you want to perform a database conversion? Now what this is doing is taking these characters we see, general alarm, smoke, SMK, all of that, is turning it to zeros and ones. So when it downloads, the CPU or the computer side of the fire alarm system understands what we're writing. So now it's going to do a whole compile, make sure everything is good to go to the zeros and ones. And then at that point, you're done. Essentially, if you had all of your rules inside there, at that point, you are absolutely done. Then from there, you will go over to Tools, Communications, and then you will have all of your information here. You have your application code, your bootloader, and your database. You don't need to download your application code or your bootloader. What it's going to do is bring that to the version of the software you're on. So if you don't want to change any revisions, you just download the database only. And if you right click on any one of these, it'll just select just that one device, whatever modules is underneath that one device. So if you have more dual controllers, it will populate them here. So any changes you make to the fire alarm system, if you add a device, if you change the character from lowercase to uppercase, you have to download the loop controller, and you also have to download the CPU. Both these cards need to understand what the changes are. Now, if you're just working on a map fault and you just changed out the same device with a new device, then the CPU doesn't need to know. Only the loop controller needs to know at that point. However, if that point had changed an address, now the CPU needs to know because it didn't know that there's an extra address to this system. So now we need to adjust the CPU. So hopefully that don't confuse you. Just in short, if you make any new changes to the system, both cards need to know. If you're just making the same changes to the system, swapping out a device for a device, only the loop controller needs to know. So here at this point, you have your no downloads, like all of them to download, just the mismatched versions, download all from 3SAC and yada yada. So here you will select all downloads, connect to either your CPU or the loop controller card. Make sure you're on network if you're going to connect to the CPU, so that way it can transfer the information over to the SDDC card. And if you connect directly just to the SDDC card, then that's just a single step. So just make sure you have that right, or you're going to have like communication errors. So we got 2 more rules to write. We're going to write one for the pull and one for the water flow. And on the pull station, I'm going to purposely give an error. So we're going to go pull station. Let's call it just pull station. So we go alarm, pull, comma, quotation. And then what is the label? Pull_1, because we only have one, right? Got to put the semicolon, or got to put the colon, I should say. So now, pull stations don't shut the fans down. Pull stations only will turn on the horns and strobes. So how to make this easy, we just copy all of this, Control-C, come back to here, hit that Control-V, and then all we got to do is just take out the fans. And then just, if you want to be neat, turn it like that. But if we don't close out the rules properly, we're going to get a syntax error. So I'm going to show you how we get a syntax error. Let me just add the water flow real quick. Water flow will shut everything off, shut the fans down, release the doors, horns and strobes, things like that. So now you don't know you have this error. So we're going to save it and we're going to close it because we're going to try to compile it. So now we go to rules, compile. Oh, there we go. Syntax error, view compiler message for details. So now it's telling us where the compile at really. It stopped where the problem was at. And that's alarm pull station. So now we'll go here and it's telling us that the rule compile has invalid command for the rule pull station. All right, so let's see what that is. I don't know what it's talking about. We're trying to figure this out. So now if you can't figure it out because you don't, a lot of times you're just staring at a screen and if the gens editor is not there for you, what the gens editor is that these texts will be color coded, and if it's wrong you'll have I believe it's probably red, or I'm not sure, you'll have a different color if it's wrong, and if it's right it's another color. It's red and blue, but I'm not sure which is which because I don't use gens editor. This is literally how I program without gens editor. So say like you can't figure out what the problem is inside of the pull station input statement, what you can do is just add the French brackets, make sure it's at the beginning and end of whatever you want to ignore. So we want to just ignore just all of this right here inside of the French brackets. We hit save, then we exit, then we go back to rule, compile. We don't want to see the warnings because we don't care. And then yes, so now we know that we got to work on that rule pull station because we know the other two input and output statements are good. We know the smoke detector is good and we know the water flow is good. So now it's a fresh new day. We come back to the rules and we look and be like, oh man, that's a comma. I thought that was a semicolon. So now we place that semicolon. Actually, we delete the French brackets, place the semicolon because we understand it now. Then we click save, we exit, then we go back to rules, compile. Again, yes, we don't care about the warnings. And yes to all. Now it's gonna compile the whole entire rules. We just saved the day. We don't have to tell nobody we messed up. Now we the fire alarm experts. So once we're done, like I said, you will go over to tools, communications, right click on the loop controller, left click on the CPU, get rid of the bootloader, get rid of the application. And if you have multiple CPUs, if you have multiple loop controllers, all of them will populate here. Then you click download. Make sure you are connected by the network, COM, whatever your COM port is. Baud rate is 38400. That's standard by default. And just click download. You should be fine after that. Then after you download, the system reboots. You just test it to make sure it actually works in the way you programmed it. So if you have any questions on EST programming, any type of specific rule programming, if you want to see rule programming for like a high-rise building, I can show you how to do that as well. So the fire alarm expert out. Talk to me in the comments. Peace.